Let's get right into it. Number 10. Cosmic Radiation Karaoke. Imagine you're at a rave held by the Milky Way and the headliner is a drum solo made of particles moving at ridiculous fractions of light speed. Those are cosmic rays, protons and atomic fragments hurled at you by exploding stars, the sun having a bad day, and other space stuff that doesn't RSVP. You're surrounded by a steady drizzle of them. Your body is technically a tiny, slow-motion meteor shower. Mostly it's fine. Your atmosphere and magnetic field are like bouncers. They take the brunt, scatter the crowd, and toss out the rudeness. But every once in a while a high-energy particle slips past and hits your DNA like a text with terrible punctuation. It can break strands, mutate bases, or signal your cells to freak out. Let's not be theatrical. The doses you get walking to the grocery store are negligible. The real horror for your biology is cumulative and situational. Astronauts in low Earth orbit get more of these VIPs in their bloodstream because the bouncers are off-duty up there. Also, if you move to Denver, your altitude invites more cosmic rays because there's less atmosphere to act as a filter. And if the sun throws a flare tantrum, solar energetic particles can spike the radiation rate and make satellites sulk or astronauts wish they were home. Here's the weirdly poetic bit. These random hits are part of evolution's sloppy toolkit. Occasionally a mutation helps. Most times it's neutral, sometimes it's garbage. So cosmic rays are like the universe's inefficient contractor, tearing down a wall when you only asked for a new light fixture. For the dramatic finale, if you lived in a place with less atmosphere or somewhere close to a star behaving badly, your cells would spend every Tuesday filing tiny damage claims. Basically, your DNA is on a cosmic open mic night and occasionally gets roasted. The universe isn't trying to be personal, it's just loud and reckless. Number 9. Black Hole Kisses. Okay, so you've heard the terrifying lullaby, fall into a black hole and be stretched into spaghetti. It's not entirely marketing. Tidal forces near a black hole do literally stretch objects because gravity near the event horizon isn't polite or uniform. But here's the thing, for most black holes, especially the stellar mass ones that come from dead massive stars, you'd notice a few inconvenient things before being elegantly served as pasta. Gravity gradients, the difference between feet and head, get intense pretty close in. If you could stand far enough away, the hole would be harmless background furniture, a dark spot on the sky that isn't even trying to kill you. The universe's more malicious use of black holes is indirect. Supermassive ones at galactic centers can get cranky. When they feed, they belch jets and radiation that can strip gas away from star-forming regions, effectively turning a nursery into an empty lot. If one of those jets was conveniently aimed your way and you were within its blast radius, your planet's atmosphere would not survive the invitation. Also, black holes aren't picky about what they swallow, wander too close and your lunch. But cosmic distances are vast, which is the boring stability you rely on. Still, black holes are a great example of cosmic indifference. They don't hate you. They don't love you. They just obey gravity like it's an instruction manual. If the universe wanted to be dramatic, black holes make the best romantic leads. Mysterious, silent, and lethal on a logistical level. Think of falling in as less of a homicidal intention and more of a very specific, very final drop-off service. Spoiler, the receipt is eternal. Number 8. Supernova House Calls. Picture your neighborhood star suddenly deciding to throw the loudest party in the cosmos and then explode out of spite. That's a supernova, a catastrophic finale for certain massive stars, and it's one of the universe's most theatrical ways to ruin a planet's week. When a nearby star goes bang, it launches a shockwave of high-energy particles, X-rays, and gamma radiation. If that blast is close enough, we're talking tens of light years, not hundreds, it can gnaw away at Earth's ozone layer, change climate patterns, and rain down secondary particles created as the initial blast slams into our atmosphere. The worst-case scenario isn't immediate incineration but ecosystem-level chaos. With the ozone thinned, ultraviolet light floods the surface, phytoplankton populations crash, food chains wobble, and the whole biosphere gets an unwanted makeover. There's even speculative evidence that past mass extinctions may have been nudged by nearby stellar tantrums. And if a supernova lines up a gamma ray burst toward you, that's the cosmic equivalent of being in the path of a very focused, unpleasant hose of energy. It can sterilize half a planet's surface-facing hemisphere in relatively short order. But before you start hoarding canned beans, note 2 comforting facts. 1. Such destructive supernovae are rare in our galactic neighborhood, and 2. Most likely candidates are far enough away to be dramatic but not civilization-ending. Still, the universe doesn't need to be consistent to be dangerous. A single unlucky star at the wrong time can flip the ecological table. So next time you think of cosmic scale as poetic, remember, sometimes the poetry arrives with fireworks and a long ecological hangover. The universe is basically throwing house parties and occasionally forgetting to tell the hosts they live there. Number 7. Gamma ray burst roulette. Imagine the universe spinning a revolver and you're standing in the line of fire. That's what a gamma ray burst feels like conceptually. GRBs are insanely powerful jets of energy, often born from collapsing stars or merging neutron stars. They're narrow, laser-like beams that shoot across space, and if Earth happens to be in their path, we don't even get the courtesy of a warning shot. 1 second you're scrolling memes, the next your planet's upper atmosphere is fried like an egg on a highway in July. What makes GRBs extra insulting is how directional they are. These cosmic death rays don't even spread out evenly, they're focused, like the universe deliberately aiming a flashlight directly in your eyes while ignoring everyone else. If Earth ever got tagged by one within, say, a few thousand light years, it could wreck our ozone layer, dump ionizing radiation everywhere, and leave the surface basking in cancer-causing UV. Congratulations, you've just unlocked speedrun extinction. The best part? GRBs are super rare and mostly happen in other galaxies, which is both comforting and disappointing. Comforting because you're unlikely to be fried tomorrow, disappointing because your lizard brain kind of likes the drama. Scientists even speculate that ancient gamma ray bursts might have contributed to past mass extinctions here on Earth. So it's not just sci-fi villain energy, it's potentially part of our fossil record. At least when you get obliterated by a gamma ray burst, it's fast. No slow simmer, no multi-generation panic. Just a cosmic off switch. The universe doesn't always need to throw a tantrum. Sometimes it just points a spotlight, clicks the button, and boom, curtain call. Basically, it's Russian roulette, but the gun is a collapsing star and you're sitting in a very unlucky seat. Number 6. Rogue Planet Smash. Imagine a planet. No star, no orbit, just a lonely billiard ball drifting through interstellar space. These are rogue planets, and the Milky Way might have more of them than stars. They don't glow, they don't announce themselves, they just quietly wander. Which means that, technically, one could be headed our way right now, hidden in the dark like a cosmic freight train with the headlights off. If a rogue planet actually collided with Earth, it wouldn't be subtle. We're talking instant planetary redecoration, oceans boiling, continents colliding, atmosphere shredded. But even a near miss would be catastrophic. A rogue planet's gravity could tug on our orbit, stretch our tides, or destabilize the solar system's delicate clockwork. The universe doesn't need a death ray when it has giant blind wrecking balls casually swinging through space. Here's the extra creepy part. We probably wouldn't know until it was close. Space is enormous, but rogue planets are dark, cold, and nearly invisible. Detecting them is like trying to spot a black marble rolling across a football field at midnight. Astronomers have spotted candidates by how they lens background starlight, but in general, the cosmic bowling alley is way too big for us to track every spare ball. So yes, the universe could casually yeet an invisible planet into our path and ruin your weekend plans. The only silver lining is that the odds are extremely low, but low doesn't mean zero. Sleep tight knowing space is basically full of wandering orphans that could one day crash your house party. The universe is less out to get you, and more, doesn't care if it spills its drink on your carpet. Number 5. Vacuum Decay Lottery. This one sounds fake but isn't. What if the universe itself suddenly decided its on setting was temporary? That's the idea behind vacuum decay. The possibility that our current reality exists in a false vacuum, a sort of temporary energy state. If that's true, then somewhere, someday, a bubble of true vacuum could spontaneously form. And this bubble wouldn't just hang around politely. It would expand outward at nearly the speed of light, erasing everything it touches. Not just people, not just planets, but the actual physical laws holding your atoms together. Talk about extreme remodeling. The comedy of horror here is that you'd never know it was coming. One moment, you're alive. The next, reality gets patched with an update you weren't consulted on. It wouldn't even hurt. It'd be the fastest cosmic hit and run in history. Honestly, if you had to choose a way to go, this might be the least stressful. The anxiety part only exists because we know it's theoretically possible. The science comes down to quantum field theory. Our universe sits in an energy valley, but maybe not the lowest possible one. If it's just stuck in a false valley, then a more stable valley exists somewhere deeper, waiting to override us. It's like discovering the floor you're standing on is actually temporary scaffolding. It looks solid until one day it isn't. So yes, the universe has an optional self-destruct mode baked right in, and we wouldn't even see the explosion, just a silent, invisible wall rewriting physics as it rushes past. If cosmic threats were a lottery, vacuum decay is the jackpot nobody wants to win. At least it would cancel all your deadlines instantly. Number 4. The Sun's Retirement Plan. Your star looks all friendly right now, sipping plasma cocktails and shining gently on your plants. But give it a few billion years and the Sun is going full midlife crisis. Eventually, hydrogen in its core runs low, and the Sun swells into a red giant. Not a gentle, gained a few pounds, swelling, more like, I ate the entire buffet and the building too. At peak bloat, it could expand past Mercury, Venus, and quite possibly Earth. Best case? Our planet gets roasted like a marshmallow on a bonfire the size of the solar system. Worst case? The Sun actually engulfs Earth, digesting us into stellar plasma. Even if we dodge being swallowed, we'll be left orbiting way too close to a star that's blasting off its outer layers like it's had one too many at the bar. The oceans boil, the atmosphere escapes, and Earth becomes a crispy rock, starring in the universe's saddest cooking show. And when the Sun finally stabilizes, it will collapse into a white dwarf, a small, dense ember, surrounded by a glowing planetary nebula. Which is cosmic shorthand for, the party's over, here's the corpse art. Life as we know it won't survive, but at least the neighborhood will look fabulous in space telescope photos. So yes, the same warm ball of gas that lets you have beach days and Instagram sunsets is also on track to barbecue everything you know and love. The Sun's retirement plan doesn't include you, unless you count turning you into vaporized stardust as part of the benefits package. Number 3. Asteroid Bullseye. Forget Hollywood meteors with Bruce Willis soundtracks. Real asteroids don't announce themselves with orchestral music. They just show up like a drunk guest at 3 a.m., banging on your planet's door. Earth has been smacked plenty of times in the past, most famously with the Chicxulub impact 66 million years ago that wiped out the dinosaurs and left a permanent, don't mess with space rocks, scar in Mexico. Now, the good news is that small asteroids burn up in the atmosphere all the time, giving you shooting stars instead of apocalyptic fireballs. The bad news is that occasionally bigger ones get through. A city-sized rock hitting Earth would mean regional devastation, tsunamis, climate disruption, and a very awkward dinner conversation for humanity. A continent-sized one? That's game over, thanks for playing. The creepy part is how little warning we'd get. Some of these space rocks are sneaky, dark, hard to spot, and only noticed when they pass uncomfortably close. Astronomers do track thousands of near-Earth objects, but thousands isn't all of them. It's like watching a few hundred ants and pretending you've counted the whole colony. So yes, the Earth is basically playing dodgeball against a universe with infinite throws. Every time you look up at a clear night sky, you're seeing stars, but hidden among them is the potential for an unwelcome bowling ball hurtling your way. The dinosaurs didn't have telescopes. You do. Not that it'll help much if the rock is already booked for an Earth check-in. Number 2. Magnetic Field Meltdown. Earth's magnetic field is your invisible superhero cape. It deflects solar wind, keeps cosmic radiation manageable, and makes compasses do their little needle dance. Without it, the sun would strip away the atmosphere like it's peeling an orange. Goodbye breathable air, goodbye oceans, goodbye weather that isn't space trying to kill you directly. But here's the plot twist. Earth's magnetic field flips every so often. North becomes south, south becomes north, and the whole magnetic shield does the hokey pokey. These reversals take thousands of years, and during the in-between period, the field weakens. A weaker shield means more radiation making it through, satellites frying in orbit, power grids having meltdowns, and ozone holes big enough to make sunscreen companies rich. Now, don't panic. The last flip was about 780,000 years ago, and the planet didn't explode. But a weakening field could make life harder for technology and ecosystems today. Migratory animals that rely on magnetic cues might go on unplanned vacations, while humans would have to deal with more cancer-causing radiation and fried electronics. Basically, your phone dies not because you forgot to charge it, but because the planet's magnetic personality went bipolar. It won't kill Earth outright, but it would turn modern life into an electrical nightmare with a side of radiation exposure. The universe doesn't always swing a wrecking ball. Sometimes it just flips your compass upside down and laughs while you scramble. Number 1. The heat-death hangover. So here's the real kicker. Forget asteroids, forget gamma-ray bursts, forget the sun's bloated retirement belly. The universe itself has an expiration date. It's called heat death, and no, it's not as metal as it sounds. It's basically the cosmic equivalent of running out of Wi-Fi signal forever. Energy spreads out evenly, stars burn out, black holes evaporate, and eventually, everything is so cold, empty, and uniform that nothing interesting can happen. No stars, no galaxies, no chemistry, no, oops, a rogue planet hit us. Just a flat line of absolute boredom stretched across infinite time. Your great-great-grand descendants, assuming humanity figures out immortality, AI babysitters, and universal dental care, wouldn't be roasted or blown up. They'd just slowly watch the lights go out, one by one, until the sky itself turns into a dark, silent graveyard. Even black holes, those drama queens of the cosmos, eventually vanish by leaking Hawking radiation into nothingness. The last flickers of energy will be tiny photons barely capable of existing. In that future, no matter how advanced life gets, physics itself would slam the door shut. No energy left to run machines, no stars left to colonize, no cozy habitable zones to cling to. The universe would just coast into perfect stillness. The final insult? Nobody would even be around to notice. Existence just fizzles out like an unplugged fridge. So yes, the universe is technically trying to kill you, but its long game isn't fire, explosions, or drama. It's giving you the ultimate ghosting, silence, darkness, and eternal nothing. And if that doesn't creep you out more than black holes and asteroids, congratulations, you've officially achieved cosmic nihilist status. That's all for today. I'll be making similar videos in the future. Subscribe to see them.